Guys, this is video 1.8. We're going to continue dealing with these things called Sig Figs, but now we're going to apply them to calculations. And this is something that we're going to use the rest of the school year. So again, if you have not mastered counting Sig Figs, pause this video, go and do extra practice, ask questions of your partners and me as well to make sure you really master that piece first before moving on to this. General rule of thumb here is that the final answer must be expressed in the lowest amount of Sig Figs, okay, that were originally given to you. So you're looking back to the original number. That's the key. Okay, look at the original number. Now there's two sort of rules. When in doubt, go with this one right here. In Regents Chem, this is the one that you're going to be more used to dealing with. So when in doubt, guys, look for the least number of Sig Figs that are given to you. So this rule applies specifically to multiplication and division. However, when in doubt, go with the least number of Sig Figs of any number. So the first thing, before you even worry about doing an example, figure out how many Sig Figs you have. So if we take a look, oh, there's my decimal, so I'm going to go from the left. When I count it up, I have 5 Sig Figs here, and this second number, I have 4 Sig Figs. Okay, so do the calculation out. Okay, write the entire number out, then we'll worry about rounding at the end. Okay, so when I do this math, I'm going to get an answer that is 14.242634. Okay, so the end result, now that's way too many. So if these were measurements that we took, let's say one device, the first one, you know, it's going to read to the hundredths place. We're estimating to the thousandths. Same thing with the second one. They're kind of measuring to the same amount. However, one is 12 and one is 1, so that's how they get a different number of Sig Figs. So we can only report our final answer to the least number of total Sig Figs, which is going to be 4 in this example. The trick here is to count out. Okay, I have a decimal, so I'm starting at the left side. 1, 2, 3, 4. Those are the 4 that I'm going to keep. Okay, now in terms of rounding, we would look in this case to the 5th number. And that's going to be our guide as to how we're going to round, whether we're going to round up or down. Less than 5, we round down. Greater than 5, we round up. So our answer here would be rounded to 14.24. Okay, so multiplication and division, we are going with the least number of Sig Figs total in any number. Addition and subtraction, guys, gets a little bit more dicey. We're looking at the lowest number of decimal places, okay? The decimal places are giving us a clue into the accuracy of our measurement tool, okay? So we're going to look for the least number. So again, do the math like you normally would. So here, when we do this math, add up 3.95 plus 2.879 plus 213.6, okay? When we add all those numbers up, we would get 220.429. Every single problem, start by doing the math, then worrying about the Sig Figs at the end. So I'm going to take a look here. I've got 2 decimals in the top. I've got 3 decimals in the second one. I've got 1 decimal here in the last, okay? So with addition and subtraction, it does kind of help to make sure, or to kind of rewrite our numbers in this order so you can kind of have all the decimals lined up. You don't necessarily have to. Just know, okay, I've got 2 decimals here, 3 here, 1 here. Okay, so I'm going to round to 1 decimal place. So that's going to be this 4. So again, I'm looking to the number next to it, to the right of it, to see how I'm going to round. And I would round down there because it's a 2. So I would get 220.4 would be my answer there. Okay. So I want you guys to pause the video. I want you to try these 2 problems on your own and then come back and check your answers. So first one, we're subtracting, so we're going to look for the least number of decimals. So go through, if I take a look, okay, 2 decimals is what I'm going to have, so my final answer is going to be rounded to 2 decimals. You should end up with 2.84. Again, our rule here that we used is the least number of decimal places. Okay. Second problem. We're dividing, so now we're going to look at the least number of Sig Figs. So my first number has 4 Sig Figs. My second number has 3 Sig Figs. All right, so I'm going to do the math. When I do the math, I'm going to round so that my final answer has 3 total significant figures. So our rule that we followed here was the least number of total Sig Figs in any number. Okay? Now, When it comes to scientific notation, guys, keep it simple. don't get hung up with this work right here, okay? You're still going to look, when in doubt, least multiplication division, least number of sig figs, and with your addition and subtraction, it's a little bit more dicey, but honestly, guys, this is going to be kind of a one-case scenario here. Don't stress so much about this. You're not going to be asked to do a lot of addition, subtraction with scientific notation per se. We're going to be definitely doing more multiplication and division. Okay, so addition and subtraction, all values must have the same exponent. Result is the sum or difference of the mantissas, which remember is just the number out in front, multiplied by the same exponent of 10. So basically what that's saying is here, before we can do this, we're going to get these into the same exponent. So what I'm going to do is I'm going to make this 45 times 10 to the 5th. Now, is that proper sig fig, or excuse me, proper scientific notation? Absolutely not. But it's going to make it easier for us to subtract when we do that, because now they have the same exponent. Okay, so when we subtract that, we would get 42.7 times 10 to the 5th, which then we would rewrite in correct scientific notation of 4.27 times 10 to the 6th. Again, don't stress so much about this one, guys. It's not really going to matter. You might be thinking, well, what about the decimals? Well, guys, decimal places, when we write these numbers out, okay, this would be 5 zeros after it. Notice how it didn't have a decimal place there. This guy right here also didn't have a decimal. That's why now we have a few different numbers here, but that doesn't matter. Okay, so don't stress about that. Now, multiplication, again, multiply, and then you add the exponents, going back to basic math here. So this would be 15.531 times 10 to the 7th is what we would get. Again, your calculator will do this for you, so I'm kind of going through the rules, guys, but you're going to mostly just plug it into your calculator. Now, if I was going to round this answer to the correct number of sig figs, how many would I round it to? I would have to make sure that I have two significant figures here. So I've got 3 there and 2 here. So my final answer here, guys, I would have to round, if we're talking about sig figs, to 1.5 times 10 to the, actually it'd be 8th here. Okay, because that 15, we would rewrite that as 1.5531 times 10 to the 8th. So let me do that. I didn't realize that. My apologies. That would be proper scientific notation. So then we could round it to correct sig figs from there. Why don't you guys try the next one on your own and see if you can figure it out. So again, divide it, plug it in your calculator. Your calculator is going to give you an answer of something like maybe 0.885 times 10 to the minus 1, or if you follow the rules where you divide the mantissas and then subtract the exponents, that's what you would get. Okay, but when we write it in proper scientific notation, your calculator may have done it for you this way: 8.85 times 10 to the minus 2, or your calculator could have just put it in the decimal form, 0.0885. But again, if we're talking about sig figs, how many sig figs? Well, this one's got 3, this guy's got 5. Our final answer, we'd want to have 3 sig figs, and it would be that right there. Okay? So, this is something that we're going to come back to throughout the year. Okay? This is the piece up here you want to remember. Okay? That's the big one. When in doubt, least number of sig figs. There's practice in the binder for it, but we're not going to spend too much time practicing it. We'll practice it within problems as we go. All right? Until next time, I'll see you later.